Good afternoon.
Good afternoon, Doc.
How was your exam? Walang sagot. Okay, are my slides showing?
Yes, Doc.
Okay, let's just wait a few more for those who are still entering. So please ask them to join the join the Zoom call so that we would have no interruptions. Okay. So for this afternoon, we would look at measurements of error, which would be the first part of knowing how to collect data and the instruments that we use whenever we do collect data. That's why the title of the lecture is Instrument and Data Collection. But we would focus on the first part because this is, we will take this up again on your second year here. Okay? Okay, so objectives for this lecture would be discuss the concept of errors in data collection, um, techniques to reduce errors in data connection, and sorry, someone for admission. Differentiate survey techniques and look at formats at creating questions and identify the errors in writing questions. Okay? So in technology, so garbage in, garbage out. So what you do, what input you do, and that would what would come out of it would be also as much or just better or worse than the one effort that you put into it. So that's the same with data collection and research. So whatever effort you put into it, and your results will depend greatly on your input. All right. But sometimes we do have errors. So review. So what are the two categories of data? We've had this in our prior lectures. And what are the two categories of data if you do remember?
Qualitative and quantitative, Doc.
So we have your qualitative and quantitative data. Thank you. So how else could you categorize further your qualitative and your quantitative data? How else could you describe your data? Yes, it's qualitative and quantitative. If it's quantitative, what are the subcategories? Quantitative, you have your numbers. So if it's numbers, how else could you subdivide your numerical data?
Continuous and discrete, Doc.
You have your continuous and discrete. Okay, that's good. If it's qualitative and it's your descriptive or you have your characteristics, what how how else could it be subdivided? So it could have a ranking or it could have none. So that is your nominal and your ordinal. So we also had tackled sources of data. So we have various sources. So namely your journals, primary source, secondary source, etc., etc. Okay. Three types variations we will talk about that. Okay. So for instruments, so these are tools that researchers use to collect data for researcher studies. So these would be your surveys, this would be your experiments, etc., etc. But using your instruments, we have to make sure that they would not produce any error. Thereby, it has the highest validity and highest reliability. These two terms we will define in the latter slides. And of course, the greatest ease of administration, scoring, and interpretation. Remember, if you are given a 5-page, 10-page survey, I think you would not finish it up to the end to answer it unless you're really interested in getting the results. Okay? So that's why we limit our surveys to 1 to 2 pages. Okay. So this is your issues in using instruments. Okay? And that is validity. So validity is defined as the degree to which the instrument measures what it purports to measure. So what it is supposed to measure is the one that is being measured. Okay, for example, do you have any idea what a pap smear is for? Even if it's lay, not for the medical practitioner yet. What would be the common notion what a pap smear is for? And what is it really for?
Doc, it used for cervical cancer screening po.
Okay, it is used primarily for cervical cancer screening. However, some would use it to quantify bacterial vaginosis as an infection. So for measuring bacterial vaginosis using the pap smear, is it valid if if we apply this definition of validity? No, because it wasn't designed to measure bacterial vaginosis. Although in the slide you will see mentioned by the pathologist that bacterial cells +1, +2, +3, or +4. But you know, and you will eventually learn that the gold standard in diagnosing bacterial vaginosis would be using an Amsel's criteria. Okay. Details of which you will learn later in obstetrics. So you have to make sure that your instrument measures what it is supposed to measure. Okay? The concept of validity clear as opposed to compared to your reliability. It's the degree to which the instrument consistently measures what it is supposed to measure. A common example would be a PP apparatus. So it measures your blood pressure. But of course, there are different reasons which we will tackle in next week's lecture. Different reasons why an instrument could be inconsistent. So, so how reliable is your BP app to show that it is always 120/80? Or that infrared thermometer for that matter. How often have you seen an infrared thermometer show 32, 33, 34? Aba, buhay ka pa? Sasabihin sa'yo ni guard for not knowing, ay ma'am, 34 po, with gusto. Diyos ko, gusto, nagpapanting-teng ako. Is it because of the instrument? Not reliable, galing China. What else? What else could be the sources of error in this case? Kaya nagiging 34. Think. One is the instrument, that's correct. One is the observer. Observer. Sa dami ng taong pumapasok sa mall, halos papunta pa lang sa noo, pinipindot na. So, kaninong temperature lang kinukuha? Temperature ng hangin. O, talagang lalabas siyang 34. O malayo pa, wala pa sa distance. So, those are things that could happen. But used correctly, the degree to which the instrument consistently will measure what's supposed to measure is said to be reliability. Okay. So, using these concepts, we have also precision and accuracy. Okay. Precision is free of random error. Okay. Accuracy is free of systematic error. So, remember this bullseye target. Okay. Systematic error. Consistent siya off target, but very what? It's still very precise. Kasi consistent naman siyang nandun. Okay? What could be an example of this? A wrongly calibrated sphygmomanometer would consistently give you -10 or -20, or your wrongly calibrated weighing scale. Kaya nga 'di ba in chemistry we always tare the machine to 0 so that it would have a good reading. Okay. So random error or random variation or bias or systematic errors, this one would be your random error that is scattered. So sometimes this would be, these are sometimes called outliers as well because it's systematic. Sometimes it would happen. Okay, so could you be accurate without being precise? Could you be precise without being accurate? So you could be precise, but you are not on target. So precision could be present without accuracy. Okay, but accuracy cannot be present without precision. Okay, so you have had reliability, validity, precision, and sorry, napindot. You have your accuracy, validity, precision, and reliability. Okay. So random errors. So how do random errors occur? Okay. So you've had your sampling lecture. So your random errors arise from your sampling variability or chance. So this either inflates or deflates through measurements. So for example, the sample that you got, merong outlier, sobrang taas ng grade or sobrang baba. So that could be a random error. Okay? So factors that contribute to random errors would be poor precision, sampling error, and errors in measurement. So it is not precise. Your sampling error would not be the best sampling frame or the best sampling method appropriate for collecting data. And you have your errors in measurement as mentioned. How to reduce? Okay, you increase your sample size. So this may increase precision or reliability of measurements. Of course, the ideal would be testing the whole population, but that is not just feasible all the time. Sampling errors, so values obtained from a sample would differ from those in the total population. That's why we use statistical tests to evaluate the role of chance in these cases. So we have to standardize and train observers so that we have consistency of measurements. So we first met that, for example, in chemistry, you have to measure your volume at eye level of the liquid in the graduated cylinder so that you will see the actual line and not just look at it at any angle convenient to you. Okay. So you have different biases or systematic errors. So what are these bias? So it could be selection bias. Pag select pa lang ng respondents, you are already biased. Okay? So this one, any error because you identifying the study population, there's already an error. This one occurs when you choose the respondents that you would include in your study. So you have different probabilities of being included in the study sample. So based on either exposure or the outcome of interest. Okay? So there are different types of selection bias. So there's prevalence incidence bias. So this is the selection of the study population. This is influenced by the selective survival of prevalent cases. Okay. So for example, what would have a high prevalence? So you would look at your um, stroke, your chronic diseases, etc., compared to acute stroke. Of course, prevalence would be higher in hypertension, diabetes, compared to stroke patients, etc. So it would depend on the survival of prevalent cases. So Bergsonian bias or admission rate bias, these are subjects taken from hospitals and already those would be a select group of subjects. Okay? Gusto ko dito, ang favorite nyo pagdating ng second year, do a research among JFSM students, etc. Or University of Perpetual Help students, etc., etc. Those would have certain biases as well. Of course, people who do not participate are likely to be different from those who give consent. Ito yung mga pasaway. So, non-participation bias is also a factor of selection. So, for example, in your sampling frame, you get someone who is a non-participant. So, the mere fact that you have a non-participant, again, gives you the notion that your sample would not be homogeneous because by your non-participant, it just goes to show that you have already a different respondent already. Okay. We're included for this healthy worker bias. So the reason that workers as a whole tend to be healthier than the general population or the medical worker bias, mga exposed na to certain interventions, so they would know the correct answer, so that they would have different results as well. So ito, sumali initially pero nag-drop out. So this is your migration or dropout bias. This occurs when members drop out over time. So the characteristics of the remaining subjects would differ from those who were originally included and eventually dropped out. Okay? Okay. This one, volunteer bias. So this would be the veterans in research studies, etc., etc. So they would have a different background and characteristics as well. Of course, if you get the wrong sample size bias, it would have the inability to detect differences arising from the inadequacy of the sample size. How do you control selection bias? So we restrict, we narrow the range of characteristics of subjects. So this would be the inclusion and exclusion criteria. We randomize. You have seen your sampling method so that we equalize the probability of a respondent to be able to be part of the study, and matching. So we equalize the distribution of extraneous variables. So for example, we get equal number of males or females, we look at the age, etc., etc., and we match them so that they would more or less you are able to control biases. Okay. You could stratify, compare rates within subgroups, and you adjust your multivariate. So this would be adjusting the effects of variables observed in order to determine the independent effect of one. So most often this is found when you have your confounding variables and you have a lot of variables that may affect a certain outcome. Okay? And you have to determine which would be the independent effect isolated from which. Okay? So another bias would be your information bias. So this results from errors committed during measurement of exposure, factors, or outcomes leading to misclassification of subjects in one or more variables. So information bias results to a distortion of the estimate of effect. So you will eventually learn strength of association as well in your latter lectures. The types of information bias, you have your interviewer bias. Of course, as the interviewer, we all have differences in getting, recording, interpreting information from subjects. Okay? So each of us will hold a certain bias among certain things. So the mere fact that you have different interviewers would have a bias as well. Later on, we will see how this would be remedied. Abstractor bias, probing more thoroughly among known cases compared to the controls. So you would look at the landmark cases, you know what would have expected results, and that could be your bias. And this could be remedied by blinding. Recall bias, so cases are more likely to recall events related to illness than controls. So if it's eventful, something happened to your intervention, then most likely you can recall. So for example, you come across a lot of people. One would have a limp. So because that person has a limp, you would have a bias to recall that person because it is related to something, some illness or something different. Prevarication, so these could be false responses from subjects. It does happen. Not all subjects are truthful all the time. So for example, when you do your research, you have your Hawthorne effect. Okay, your Hawthorne effect is doing something when you know that you are being observed. For example, you know that you are being observed in the operating room. So you would take more precaution in following your infectious protocols, your hand washing, etc., etc., etc. And that is the Hawthorne effect if you know an observer. Remember when you were in elementary, there would be observers coming into the classroom to assess the class or to assess the teacher, and what do they usually do? Sometimes they just repeat the previous lecture of the day, and then the students already know the answers so that they would get a good evaluation. So that happens. And that happens not only in the classroom, it happens in other situations as well. Okay, how do you reduce? So as I've mentioned, you do blinding. So you blind the interviewers, you blind the participants. Of course, if you do both, that is your double blind. Okay? So the interviewers do not know what what would be the outcome as well as the participants. Standardized training of observers. This is when, for example, you do your objective clinical examination, you do have a checklist to follow so that your observers will look for certain things that you have to do, minimum pass level to pass the examination. Okay? Standardize your data collection tools. Okay, so you standardize both the observer and data collection tools. You make a panel. So if you have one interviewer, so that there would be no bias, usually what is done would be to make a panel of interviewers, usually three, so that they concur if they agree with the evaluation of the interviewer. And of course, your pre-tested questionnaire so that you know if your questions are adequate or not. Okay? We use memory aids, charts, or figures. Okay. Confounding is a variable that distorts the estimate of effect in analytic studies due to the influence of an extraneous factor. So the crude and adjusted measures of effect are not equal. Okay? So the characteristics of confounders, so it's neither the independent nor the dependent variable, and this may also be a risk factor for a disease outcome. Okay? So it is not an intermediate step in the causal path between exposure and disease, and it is associated with both dependent and independent variables. So an example of a confounder would be looking at the effect of the association between air pollution and bronchitis. So what do you think would be the effect of air pollution and bronchitis, and what could be a confounder? Any idea? Overcrowding. So it is not your independent or your dependent variable, but both would be associated with air pollution, with overcrowding, both air pollution and bronchitis. So it both affects the two entities, but it is not the variable. Okay. And what will the effect of your confounders be? So it distorts your true value or degree of association. So generate a positive association when there is in fact none. So positive or negative confounding could happen. So there could be an over or underestimation of the strength of association. So the strength of association may either be reduced or increased. So for example, is being a male a risk factor for malaria? Anyone? Anyone?
Doc, no po.
No?
Um, it depends po, Doc, kung equal yung exposure.
So it would depend on the exposure. What variable would make the males have a higher exposure to malaria?
Doc, yung possible workplaces po nila.
That's good. So, as cued by the slide, male gender, malaria, your confounder would be an outdoor occupation, which predisposes the male to be exposed more to your vector of malaria. Okay? Thereby, compared to controls, you have more males affected by your malaria counterparts. Okay? So there will be more males being affected. So is there confounding? So your, I would not ask you to compute yet, but your odds ratio or your stratified. So what is important is it would be distorted due to the confounder, and it is usually um, equal to 1, supposed to be. Anything more than that, it's confounded. Okay. How do you control? Like your biases, we randomize, we restrict, and we match. Concepts we have discussed earlier in this lecture, also applicable in controlling confounding. Of course, we do stratified and multivariate analysis as well. So these are your statistical interventions. Okay? So it is important for you to minimize errors because it compromises the validity of research. So it will affect your internal validity. So this is the soundness of methods utilized in the selection of the study and the lack of error in measurement of exposure outcome and association between variables under investigation. So, threats to internal validity will be as follows: your selection bias, your history, maturation, instrumentation, and attrition rate, as well as repeated testing. So, if there are a lot of tests already and you already know what to do and what is expected from you, of course, the validity of that examination would be um, would be in question. Okay? For example, nag-ulit ng questions o ang validity ng exam non questionable. Okay? But sometimes, if you feel that if it's a repeat, because those are the very things that are important for your teacher, for according to your teacher for you to know. So for example, in obstetrics, paulit-ulit namang itatanong yan, how to compute for age of gestation, how to compute for LMP, how to compute for your bishop score, etc., etc. So, for example, in anatomy, trace the brachial plexus. Laging, lagi na lang pinapadrawing, lahat ng first year ata dumaan. Draw the circle of Willis, neuroanatomy. So, even if it's repeated, because it's a must know, we still have to repeat it. Even if we know that repeated testing would question the validity of an exam. Okay? And regression. Sana naman wag regression because some say that performance naturally declines after a duration of time. So how is this? Siyempre, pagpasok yung first year, excited na excited. First exam, tataas ng grades kasi excited. Pagdating ng 4th, 5th, 6th long exam, kaya na, papasa na ako kahit mag-aral lang ako 1 hour, ganyan. So that is sometimes where regression will come from and would have a decrease in performance. As to external validity, it refers to the study's ability to extrapolate the inferences and findings from a sample to the target population. So this is from a particular to a generalized um, statement that makes the statement universal. So for you to have an external validity, you have to have internal validity. Threats to external validity would be the pre-test effect. So if you do your pre-test and then you eventually do it on your samples, so you should not repeat your subjects by giving it again to the population that you did a pre-test on. So multiple treatment effect. So you have your data that you would not know which one would be the one that is valid. Treatment diffusion, as time goes by, you would have a feeling that your treatment would not be as effective as when you initially administered it. Experimenter effect would depend on the experimenter and reactive effect. Okay? So, thank you for listening to this lecture. This data collection, the next part would be for a latter um, lecture. Okay, I think this is for the second year once you do your research. Okay, but for the video, if you go back to it when you review on YouTube, you focus on the errors, measurement of errors, bias up to confounding. All right? Any questions?
Doc,
Yes.
ay, regarding po pala sa feedback, Doc, magkakaroon kayo ng feedback dun sa last long exam natin.
Hindi ba nag-feedback si Dr. Cruz last week?
Wala po kasi kaming Doc, yung copy ng exam, tapos hindi niya na screen share yung exam, kaya hindi na namin natuloy.
Actually, pinaalam niya sa akin kung pwedeng ibigay yung link ng exam eh. Kala ko nabigay na niya. Okay lang. I will give the
Pinost po niya sa MS Teams.
pinost daw sa MS Teams. Yung buong exam with the answers.
Yes po.
Yung MS forms. For those who have browsed through it, any questions? For that first biostat exam, was it difficult? we have reduced your MPL to 55, which was originally, he stated that it was at 60. Pero kahit 60, more than half would still not make it. So, we concurred that MPL is 55 for that particular exam. Okay? So, pero alam niyo na results nyo? Hindi pa.
Alam na po, Doc.
Alam na. Okay. Sige. Ah, anong feedback on how to answer? Pero yung buong MS Forms ba ang nakapost, Nika?
Yes po, Doc.
Tingnan ko lang, silipin ko lang. And we will have 2 weeks of walang klase. Ito. Do you have any questions in particular with the questions of the exam? Any contention? Andito pala. So you just browse through, sa mga hindi nakakita, you just browse through the answers. If there are any questions that you would want to be addressed, you just message it to me so we could discuss it when we convene again. Okay, we will have 2 weeks of no classes. I think I will just double the lecture when we resume because we would have classes, after April 9 na. So that would be around April 16. So use it to recharge. Okay? So if your recharge is studying still, well, it's up to you. But use the 2 Fridays off as a recharge session. All right? Any questions for this lecture and for the feedback? Email it, message to me what if ever you have questions, answers that you think are not correct. Okay?
Bali po
Yes.
yung April 2 po, yung fifth exam ng PMCH, mamumove po ba siya?
Kailan ba nakasulat yung 5th exam?
April 2 po.
April 2. Move na. Next week dapat. Siyempre wala. Good Friday na next week, di ba? Tama, di ba?
Yes po,
Yes
Doc.
po, Doc. Friday po yun.
Sorry, when we made the wala pa kasi yung 2021 calendar. Hindi ko na anticipate na tatamaan nga pala Holy Week kasi usually summer naman na yan eh. So, we will move the exam to may isa pang lecture. You will still have a lecture with me measures o accuracy of observations when we convene again. So, hindi pa exam pagbalik.
Okay po, Doc. Thank you po.
Okay. Any more questions?
Doc, may nagpapatanong po.
Hmm.
Kung may ma-exempt po ba sa finals, kung matataas na po yung score sa LA?
We give exemptions for grade of 75 pataas. So that is at least a 2.5.
Thank you po, Doc.
Exemptions na agad. O ba? Malapit na matapos. Okay. Try to, we try to um, look for ways to give you okay grades. Okay, you have good first sem grades anyways. So, bawi lang kayo sa second biostat exam and I think you're good. Okay? And then finals, 50% first sem, 50% second sem. Okay? So, in 100 item exam, so that's 50, 50. 50 items, 50 items. Okay. Ano pa?
Doc, just
Yeah.
clarify ko lang, yung regarding sa exemptions ni Doc, overall grade na po ba yung 75%?
Yes, it's an overall grade. Hindi lang siya exam. So, kasama yung presentation nyo, kasama your participation and quiz. Yung quizzes nyo, I could tally into one long exam. Mga ganon.
Thank you, Doc.
Okay. Any more questions? If there's none, you may leave this call. Thank you.